Hey guys, so I know we've talked a little bit about probability. Ugh, you'll have to ignore my voice. I'm stuffy. That's okay. Today we're going to jump in. We've got a lot to cover in this video. It's going to be a lot of crazy words and stuff you've probably never heard before, and that's okay. But we're going to take it slow, and hopefully you'll get the hang of it. So I'm going to give you kind of the list of what you should know by the end of this video. You should know what this symbol means. Okay. You should know and some of these you should know, like variable. We're going to give you a good definition for variable. I'm going to give you a good definition for a constant. Okay. We're going to talk about these you don't know. What a discrete random variable is. Okay. We're going to talk about what a continuous random variable is. I'm going to tell you what this x sub I means. I'm going to tell you what x means. We're going to talk about what P of x sub I means. And we're going to talk about two more words and I'll leave you alone. Standard deviation. And then we're going to pull it all together and talk about a probability distribution. That last one will be kind of putting all this together. Alright, pause and write those down. If you want to, you can go ahead and get note cards out. All of these will be a note card. And that'll be an easy 100 points if you want to. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, there you go, 10 easy ones. Okay, I know it's overwhelming right now. It won't be once we get started. A lot of these are a lot easier than they sound, but some of them aren't. So, okay, hopefully you wrote those down. If not, go back, pause, and write them out. So first one, let's talk about what this weird E is. Okay, this weird E is a Greek letter. It is a sigma. Okay, sigma. That's the name of the Greek letter. And when I say Greek letter, I mean there is just like there's an English alphabet, A, B, C, D, E, F, G, there's a Greek alphabet, alpha, beta, gamma, delta, epsilon, zeta, eta, theta, iota, all those, okay? This is sigma. What it means in math, we like to put Greek letters in math because the Greeks had a ton to do with math. They started most of the math that we use today. So what it means in math, and this would be your definition of it. I want all of this on a note card though if you're into it. It means the sum of. Okay? Sum. You better know what that means from like second grade. It means when you add everything up. So if you add everything up, that you're going to use a sigma. You're going to see sigma. So an example would be the sum of 1 through 4. Okay. Now we're going to have letters and numbers and crazy stuff after the sigma, and we'll talk about what that actually means. But the sum of 1 through 4, sigma 1 through 4. So that literally means you go 1 plus 2 plus 3 plus 4. I add up everything here and give me an answer. So the sigma, or the sum of 1 through 4 is 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10. 10. Boom. That's all the sigma means. Now, we're going to get into using it in probability in a second. But, get it, got it, done. So, sigma, that's 1 down, 9 to go. Next, talk about a variable. So, we talked about, what did we say? The two words I told you were very important in probability. Darn. I don't remember. That was like a week ago. I know it doesn't seem like it because it was 2 days ago in video time, but it was like a week ago. But these next two words are very important. Variable and constant are very, very important. A variable is simply an unknown. Okay. So most of the time, for instance, okay, let's do an equation. Y equals 3x plus 4. Okay. My variables are the unknowns. Do you know what y is? No, it's not a number yet, so you don't know what it is. So that is a variable. Okay. Do you know what x is? Wow, that blue marker does not work. Do you know? Okay, beautiful. There we go. So our y is a variable. Do we know what x is? No, so x is a variable. So one of those are variables. All right. Now, constant is its own name. If something is constant, it stays the same. So it is usually, or always, will be an unchanging we're going to say event or number. I know those are completely different, but we'll talk about it. So in an equation, a constant is, which one of these will be a constant? Now, you're going to say, oh, well, the 3 is because it's a number. No, the 3 changes because if x is 2, then this 3 is really 6. 3 times 2 is 6. If x was 3, this is really 3 times 3, which is 9. So that 3, yeah, it stays the same, but you're multiplying by something, so it changes the value. So my constant would be this guy. That's my constant. Because no matter what I get, no matter what I change y to, or this x to, I mean, no matter what I change that to, I'm always going to add how many? 4. Always 4. It's never 8 or 16. It's always just add 4. So that's what makes it a constant. It's never changing. It's unchanging. Now, an event, okay, so these also work with an event. So I'm going to put an unknown, let's change this, an unknown number or event. So for this, in this situation, in an equation, it's an unknown number. An unknown event would be, let's see, let's talk about weather, okay? If I do a forecast for tomorrow, I don't know if it's going to rain or not. So my variable will be rain. Okay, it could rain, it could not rain, I don't know. That could change. Okay. However, my variable, my constant is the sun is going to rise tomorrow unless something terrible happens. So my constant is the sun will rise and the sun will set. My variable would be rain. It could rain, it could not rain. Okay. Another example, let's talk about money. You work for a company that sells couches. You're going to sell a couch. And you get paid $3 an hour. Okay. And you make 10%. Let's change that. You make $10 a day. And you make 5% commission. Okay. Let me erase this. And I'll give you an example. So, let's write this out. I sell couches. Okay, I make $10 a day, and I make 10% commission. So if I sell a couch, I get 10% of it, of whatever I sell it for. So let's say on Monday, Tuesday, Wednesday. Okay. On Monday, how much am I going to make no matter what? If I don't sell a couch at all.
Marvin, please come to the front office. Marvin, please come to the front office.
Because I came into work, I make $10. On Tuesday, I come into work, and I make what? $10. On Wednesday, I come into work, I make $10. Now, then, on top of that, plus the $10, I make commission. I make 10%, so let's write that as a decimal. Move my decimal over two places at 0.1. Times whatever I sell. Okay. Now, on Monday, if I don't sell any value in couches, I don't sell a single couch. Okay. 10 plus 1% of 0, 10% of 0 is 10. So I made $10 on Monday. Okay? On Tuesday, I sold $100. Sold a couch for $100. One couch, $100. 10 plus 10% of 100. 10% of 100 is 10. I made $20 on Tuesday. On Wednesday, I had a great day. I sold 4 couches, making a total of $400. Alright? So I made my $10, and then I made 10% of $400. So to do 10%, I just move a decimal over. So that's an extra $40. So I made a total of $50. Okay? So these are all my values that I made. $10 more, $50. Now, in this equation, there are constants and variables. Constant. You should know this just by looking at it. My constant, what did I make the same every single day? Okay? I made $10. Every single day. No matter what, I'm making $10 because I came into work that day. Now, my variable, once again, remember, I know you see this 0.1 in all three, but that does not mean it's a constant. Why? Because it's being multiplied. It's attached to something that changes. This guy is attached, like I just said, to something that's not constant because this 0, this 100, and 400 are not the same. Therefore, my commission would be a variable. Okay? Because it could change. I could sell 5 couches, I could sell 100 couches, or I could sell no couches. Or I could damage a couch and be in the whole couch. So that's my variable. That's a real life situation where you would see this. Okay, constant variable. Hope you got it. Now, that is 3. We're a third of the way there, but now it's about to get crazy. Okay, so now we're going to talk about these big ugly words: discrete random variable, continuous random variable. Let me go back to black. Okay, discrete random variable. Can you see all the way to the top? Yes, you can. I'm going to go a little bit. A discrete random variable Okay? And then the next one is a continuous random variable. We're going to talk about both of these kind of at the same time. Continuous random variable. So looking at these, what's the difference? We know what a variable is. Okay, we know what that word means. We just talked about it. So it's something that changes. Alright? So an event or a number that changes. So we know what a variable is. Okay? Random. I feel like we all know what the word random means. It's random. Okay, so we know random. So the only thing that makes these different, no matter how big the word is discrete and continuous. Now, when you hear discrete, I want you to connect that to a word in your head. Okay, I want you to think of concrete. Discrete, concrete. Continuous, you can think of continuous. When something continuous, it just keeps going, keeps going, keeps going. Alright, now. Let me see if I can find a actual Webster's Dictionary definition. Oh, yeah, we'll leave it alone. So a discrete random variable, this is what I want you to write, is a counted, okay, outcome, and a continuous is a measured outcome. Well, that's not too hard. Well, you're right, but let's talk about what these outcomes are. So, remember I told you to think discrete, concrete, something that is there, it's solid, it's something you can actually touch or count. That's why we say counted. You can count it. I can count the numbers of chairs in this room. So, if my outcomes, this is what I want to know. I am going to, let's say, flip a coin. Okay, if I flip a coin, there's 2 outcomes, heads or tails. Not heads 0.3 and tails 0.4. No, it's heads or tails, one or the other. Something I can see, touch, count, have. I'm going to flip a coin 3 times. So let's write that. Flip a coin 3 times. Okay. What are my possible outcomes? If I flipped it 3 times, I could do, if I could get lucky, I could go heads, heads, heads. I could do heads, tails, tails, heads, heads, tails. Then I could do heads, tails, heads, tails, heads, heads, tails, tails, that's tails, tails, heads, or there's 2 more. Could I have tails, tails, tails? That's the last one. Oh, tails, heads, tails. Okay, so I have a total of 1, 2, 3, 4, 5, 6, 7, 8. 8 options. 8 countable options. Alright? So I counted those are my outcomes. Boom. I can actually see those and touch those. Now, that will be that's a discrete random variable. Would be the outcomes of a problem. Now, here are some things I want you to put under this. These need to be on your note card, okay? I'm going to give you some bullets over here. Put them in a box. I'm going to give you a box of bullets. Okay, so, can you see all my box? Oh, yeah. First bullet, countable number of outcomes. Number, not just hashtag, but number of outcomes. It's sad that your children will probably never see that and think number. They'll only think hashtag. That's kind of scary. Okay. Each outcome should have a probability. So, okay, what are the chances that I roll or that I flip a coin and I get tails, tails, tails? How many times do you see that in all of my outcomes? Nope, 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 nope. Boom. Okay. So the chances of me getting tails, 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 all tails, is 1, so there's only 1 here, out of 8. Because there's 8 total. 1, 2, 3, 4, 5, 6, 7, 8. 1/8. Boom. Okay, the chances of, let's say, that, what are the chances of me flipping 2 heads? Getting 2 heads. 3 heads, 1 head, 2 heads. Okay, 2 heads. 2 heads. Okay. So, I have 1, 2, 3 out of 8. So the chances of having 3 heads would be, or 2 heads would be 3 out of 8. So that has a probability. Remember, these are probabilities. They can be written as fractions. Okay, so every one of these has a probability. If I ask what are the chances of getting heads, 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 1/8. Chances of getting heads, tails, tails, 1/8. I can do what are the chances of getting 2 tails? 1, 2, 3. So I can find all these probabilities for these exact outcomes because I can count them and they're here. So your next bullet is each outcome should have probability. Outcome has a probability. Okay. Now, I'm going to give you 2 more bullets, but I'm going to talk about this first because they involve that XI and all that stuff. So, yeah. Let's talk about this. So, I have given you an example of a discrete random variable. You can count it. Each thing has a probability. Now, the difference, we said, is discrete and continuous. And I told you that discrete meant counted, continuous meant measured. So, those are kind of similar, you think at first. But, if I asked you to measure, give me everyone's height. Okay? I'm going to measure everyone's height. What is the probability of that happening? Like, for each person's height. For instance, what I'm trying to say is everyone in this room could have a completely different height. It's not a guaranteed heads or tails, or it's not a guaranteed of 5'5", 5'6", 5'7". You could be 5'6" and 3/8, or 5'7" and 5/16. Like, it goes on forever. In those numbers, it's infinite heights that could be there. If I asked you pick a number between 1 and 1,000, okay? Oh, well, that's countable. There's 1, 2, 3, 4, 5, all the way up to 1,000. No, there's 1.1. 1.12345 1.19835. There's an infinite number of things between 1 and 1,000. You can't physically grab and be like, here is 1, here is 2. Like, I can grab the chairs and say, here's a chair, here's 2 chairs. So the difference in these two, a measured outcome is infinite values. So it has infinite, remember that symbol? Infinite values. Okay? It does not necessarily have probability. Sometimes it does. Ability. Sorry, my handwriting got sloppy. So let me give you an example, and we're going to combine these two for a second. What if I told you a cop is sitting and on the side of the road trying to give people speeding tickets? So we've got a cop giving tickets. Now, who makes the decision on who he gives a ticket? He does, okay? So in his mind, he has a general idea. You know, if the guy passes him going 15 over the speed limit, he'll probably give him a ticket. And we wanted to, we were going to count the number of tickets, and compare them to the speed. Can you see that? Yep. The speed the car is going. Now, there is a discrete variable, and there's a continuous variable. The discrete variable is the one that can count. I kind of gave that away, I didn't mean to. Sometimes it just happens. So if I count the number of tickets, that is my discrete variable. So the number of tickets, okay, would be discrete because I'm counting it. Discrete. Okay, what's another variable in here? Okay, variable is something that's unknown. We don't know the number of tickets, and we don't know the speed of the car. Okay, so why would that be a continuous variable? Well, like I said, someone could be going 54.5 miles per hour. Someone could be going 54.51 miles per hour. There's an infinite number of speeds someone could be going during that time. Okay, so those are the difference between these two. Now, I'm going to give you some more terms to put in here. So I'm going to erase everything but my boxes. How far can you see to the left? I'm going to give you a mark right there. Okay. Now, we're going to talk about this x and this xi and all that stuff. So my x simply means that is my outcome, kind of what I'm looking for. Okay. So if I'm flipping a coin, it's what I flip. So we're going to talk about flipping a coin throughout all these. So it is what I could flip. Okay. My x sub I is each of my flips. still gonna write that, but give me a second. So that was my outcome. These are my, this is not what this should be. I'm sorry, I know. You have to erase things. These are my possibilities, is what this is. This is my outcomes. So it's what you flip. You could flip. Like it's what you... So this is what I did over here. My head, tails, heads, tails, tails, heads, so on. This is heads or tails. This one you won't see a lot. This you will. Okay? Your P of xi, let me sure I'm writing that right. I thought it was in parentheses, yeah. P of xi is the, P stands for probability of xi. So, remember my xi's are my hth. So if I said, what's the P of hth, it would have a number. It would have like 1/8. Remember we had one that was 3/8. Okay? So that's kind of what this is. Now, what this says, why I left this empty, is that your P of xi is between 0 and 1. And it also says this. Ooh, this is going to freak you out. Sigma Pxi equals 1. Okay? Let's not freak out saying what that means. What does this mean? The sum of, good, the sum of the probability of my outcomes. So if I added up all the probable outcomes, so remember I had all of these. Let's do them again. H, 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 T, T, H, H, T, H, T, H, T, H, H, T, T, H, T, H, T, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 of these, so the probability of each one is, if I just am saying what's the chance of each of these happening. 1/8, 1/8, 1/8, 1/8, 1/8, 1/8, 1/8, and 1/8. Okay, that's the probability of each of those happening. If I add all those up, what's 1/8 plus 2/8 plus 3/8 plus 4/8 plus 5 plus 6 plus 7, 8. If I have 8 8s, I have a total of 1. 8 over 8 is 1. So that is true. I added all those up. I added, so the sum of all of my P's, the probabilities of my Xi's. So this is the P sub Xi of Xi. If I added up all the blue, I get 1. That's what makes us true. So, we've done X sub I, we've done P, we've done P of X sub I. And this is already a 30-minute video. Let's stop there. We're going to talk about standard deviation and distribution, probability distribution in the next video. Alright, so I didn't fill in any of this stuff for here because if it has no probability, then I can't add up the P sub X's of I because they don't exist. Does that make sense? Okay. So I hope all of that makes sense. If not, I'm at the back table. Come talk to me. Cool.